Good morning, everybody. Welcome to a wonderful morning of chemistry, Chem 1105, with your host, me, Dr. White. And like I said, I hope you all had a great weekend. I did. All right, important things I need to talk about initially. All right, thumbs up, people. Do you see amnesty program on your screen? Wake up. Thank you, Elena. All right, let's talk about it. I talked about it last week, and I finally was able to find a time on Sunday to post it. And a number of you have not handed in labs. You don't hand in a lab, you're going to lose you're losing 10 points. And if you do 3 or 4, that's 30, 40 points. That's going to hurt your grade. Therefore, I instituted a one-time only, I believe, lab amnesty program. If you don't have a score in Blackboard for any lab that's already due, then you should email me the lab if the link is not open before this Thursday, 5 p.m. in order for me to grade that lab or the labs so you get points for the lab. After that time and date, I will enter a 0. Yes, a 0 for any lab that was due but was not submitted for grading by Thursday, 5 p.m. If you need a copy of the lab because the link isn't open, email me and I'll send it to you. If you have any problems with doing labs, come to my office hours or tomorrow, Tuesday, after lab. I'll have time to help you out. Now, this is important. I will now, and I haven't this semester, but now I will, I'll be strictly following my syllabus grading rules for labs. Labs that are late, like the one tomorrow is due, if it after that, you'll lose 2 points if it's late. After 8 days, if you haven't handed it in, you'll get 0 points. So, many of you have been handing in your labs on time. Thank you. Makes my life easier. But get your labs in if you haven't. All right, any questions on that? And again, I have my office hour tonight and Wednesday night from 5 to 6:15. If you need a special time, let me know. And also tomorrow, Tuesday after lab, I'll have plenty of time to help anybody who needs help out. All right, that's one important thing. The other important thing is calculator. From test 1, I saw a couple of you did not know how to use a calculator with scientific notation. If you don't know how to use your calculator with scientific notation calculations like multiplication division, like was on test number 1, after lab tomorrow or in my office hours, come by and I'll show you how to do it with your calculator. There hasn't been a calculator yet that I haven't figured out how to do scientific notation on. Some of the fancy ones with a little screen, it takes a little more time, but you can still figure it out. So make sure you know how to do that. Any questions on that? Well, in that case, I better get started. On Friday at the end, I started talking about mole factors and calculations. And the important thing I started to teach you, was the coefficients in an equation, chemical equation, give the fixed molar ratios between substance consumed, reacted, or substances produced, what you make in a chemical reaction. So what that means is, first of all, I have to write a chemical reaction. And this is only true for balanced chemical equations. And hopefully everybody sees 2 hydrogen, molecules react with one oxygen molecule to make 2 water molecules. But now what it means is 2 moles of hydrogen react with 1 mole of oxygen to make 2 moles of water. And this is one of the most powerful concepts outside of just what is a mole that I know in all of chemistry. This concept is so powerful. And later today or tomorrow, you'll learn how powerful it is. All right, let's look at an example. If you were in a classroom, you'd be watching me write this on the board like you're doing now. All right, let me decode what I just printed. Hopefully you can read it. If you react 8.66 moles of oxygen with an excess of hydrogen, then how many moles of water are produced? So the first thing is, what are you being asked to find? Moles of water. What are you given? 8.66 moles of oxygen. Now, in a problem like this, if you ever see an excess of a compound, like right there, that means you can ignore it, because that means you have all the hydrogen in the world that will react with anything hydrogen will react with. So at this point, we can ignore it. So how do I proceed? Well, this is the only number I have. And what units do I want my answer to be? Moles of water. And if I had a magic ratio, what would I multiply moles of oxygen to get to moles of water? And it's time to use your good buddy, your good friend, unit analysis. I love that whistle. Hopefully you do too. And how do you use unit analysis? Whatever you're trying to get to goes on top of the ratio. Whatever you're trying to get rid of goes underneath. So I'll write those things there. And where do I get these numbers? You get them from the balanced chemical equation. For every 1 mole of oxygen, you make 2 moles of water. Again, for every 1 mole of oxygen, you make 2 moles of water. Remember, when there's no number in front for the coefficient, that's the number in front of the molecule or chemical formula in a balanced chemical equation, that number is 1. So from above, I know for every 1 mole of oxygen, I make 2 moles of water. As you see, 1 mole of oxygen makes 2 moles of water. Now, it's important to know, therefore I'm going to tell you, 1 and 2 are exact numbers. You can't have half a mole, or I should say in the here, you can't have a coefficient That's not a whole number. You can't have 2.4 or anything like that. In a balanced chemical equation, the coefficients, number in front, are exact numbers. Therefore, if we look at here, we have three significant figures, and our answer should have three significant figures. Why? Because 1 and 2 don't play a role. They're exact numbers. So now I can get my calculator out, turn it on, clear it, 8.66 times 2 divided by 1, and my calculator gives me this number. However, that's not three significant figures. So I'm going to let you try rounding that off to three significant figures, then I will. Because remember, on test 2, 3, 4, and the final, it will say, please use proper significant figures for all calculated answers. And if you don't, I take off a point. All right, keep the 1, keep the 7, keep the 3. That's my three significant figures. Use the 2 to round off, and I have 1.73. This is 4 or less, so I'm going to drop it, times 10 to the first moles of water. And that's how you use the very, very, I'll say it one more time, very powerful concept. The coefficients of a balanced chemical equation give you the molar ratios of the reactants. Remember, the reactants are on the base of the arrow. And the products, or in this case, one product. And once in a while, I'll call reactants starting materials. All right. I'm going to let you try this one out first. The question is, how many moles of hydrogen, whoops, yeah, I got it right. How many moles of hydrogen will you need to react with an excess of oxygen, meaning you can ignore the oxygen, to make 4.718 moles of water? Now, I'd remind you, write down over here, what are you being asked to find? What are you being given? And then you use your good buddy, your good friend, unit analysis, and you'll need to use this balanced chemical equation, which in a problem like this, I will have to give you. And I did. Oh, by the way, hint, you don't even need your calculator for this one. Oh, I just gave it all away. And don't forget, this week is Students Turn on Your Webcam Week. Did you buy that one? All right, I think everybody's done. So I better get to work. Question is, how many moles of hydrogen? What are you being asked to find? How many moles of hydrogen? And what are you given? 4.718 moles of water. Again, you're trying to find out how many moles of hydrogen will react with an excess of oxygen. As soon as you see the words in excess of something, you can forget about that molecule, and I will. So we have this, and this is the only number we have to start with. And what units do I want my answer? Well, I took the time to figure that out. And now if I had some conversion ratio, how do I proceed? Well, use your good buddy, your good friend, unit analysis. Whatever I'm trying to get to goes on top of the ratio. Whatever I'm trying to get rid of goes underneath. So I'm going to write those units in. And one thing I forgot, the previous problem, the units we started with, moles of oxygen divided by moles of oxygen, cancel out, because anything divided by itself equals number one, meaning it's cancel out, and we got the right units. Well, let's get back to our problem here. Now, where do I find this ratio or relationship between moles of hydrogen and moles of water? And the answer is your balanced chemical equation. And this says the coefficients, 2 moles hydrogen make 2 moles water. Again, the coefficients give you molar ratios. So for every 2 moles of hydrogen, how many moles of water do I make? 2. Now, these are both exact numbers, so they don't play a role in how many significant figures your calculation should have. This has all non-zero numbers are exact, not exact, significant. I got exact numbers on the brain. And therefore, our answer should have 4 significant figures. Now, if you notice, 2 divided by 2 is number 1, So the answer here will be 4.718 moles of hydrogen. And that's how you do. Oh, let's do another one. And here's one more for you to try. Am I being polite and nice, letting you have some of the fun, a lot of it today? All right, how many moles of NH3 ammonia are made if you react 6.58 moles hydrogen, H2, with an excess of nitrogen gas, N2? Your turn. If you don't have a calculator, just set it up. Remember, on my test, it always pays to show your work. If you make any kind of mistake and get the wrong answer, if you show your work and you got a lot of right stuff, I can give you partial credit. Remember, the coefficients of a balanced chemical equation give you molar relationships. All right, I think everybody's done. Let's take a look at this. How do you proceed? First, what are you being asked to find? How many moles of ammonia? Interesting enough, I say moles, but I never put an S down there. You want to put an S here after the E, go right ahead. What are you given? Well, we've got this number, 6.58 moles of hydrogen gas, H2. And we're also told there's an excess of nitrogen gas, N2, so I can ignore it. And most importantly, you're given a balanced chemical equation. And the coefficients give you molar ratios. So this is the only number I have to start with, so I will. I had some conversion ratio. What units do I want my answer to be? Moles of ammonia. And now it's time. Anybody keeping count how many times I say it's time to use your good buddy, your good friend, unit analysis? I'm going for the Guinness Book of World Record this semester. Somebody I hope is keeping count. All right, whatever we're trying to get to goes on top. Whatever units we're trying to get rid of go underneath that ratio. And now I'll put moles of ammonia and underneath moles of hydrogen. And where do I get these numbers that would go in this ratio? You need to look at the balanced chemical equation. And this tells you, remember, the coefficients give you molar relationships. And what it tells me is 3 moles of hydrogen react with 1 mole of nitrogen to make 2 moles of ammonia, NH3. Well, if I look here, I need the relationship between moles of hydrogen and moles of ammonia. And for every 3 moles of ammonia, 3 moles of hydrogen, my brain was racing ahead of myself. That happens sometimes. You make 2 moles of ammonia. Again, the coefficients give you molar ratios. So now we have that. And before I pick up my calculator, notice moles of hydrogen divided by moles of hydrogen cancel out because anything divided by itself equals number 1, meaning it's canceled out. And I'm left with moles of ammonia. Remember, these numbers 2 and 3 are exact numbers. So how many significant figures in this number? All non-zero numbers significant, so it's 3 significant figures. My answer should be 3 significant figures. And now I can happily pick up, and I am happy, my calculator, put in 6.58 times 2 divided by 3. And my calculator gives me this number. Now, 10 to the 0 remember, now if you want to keep the 10 to the 0 on a test, that's okay, but I'm going to drop it. And how do you round this number off to 3 significant figures? Your turn to figure out. Time's up. Keep the 4, keep the 3, keep the 8. That's your three significant figures. Use this number to round off. Is that 4 or less, 5 or higher? 5 or higher it is. So everything else, afterward I drop. This I increase by 1, and the answer would be 4.39 moles of ammonia. And that's how you do that. And again, one of the most powerful concepts I know in all of chemistry is the relationship, the molar relationship of the coefficients of a balanced chemical equation, which is why it's important, which is why I'll be spending more time tomorrow in lab to make sure you know how to balance chemical equations. Now, if we look at this, well, if I start with those many moles of hydrogen, I'll make those many moles of ammonia. I hate to break it to you, I have never seen, I bet you have never seen, a balance, a scale that measures out moles of something. Doesn't exist. But what you can do is measure grams. And that's real world. And I live in the real world. I've worked in the real world. I still work in the real world. Isn't that nice? I think so. So let's move on. Let's do this reaction we've seen before. Yep, 10 points. All right. You know something? Let me change this. All right, let's go through this. 10 points. Ooh, big problem. How many grams of oxygen are needed to react with an excess of hydrogen to make 25.6 grams of water? So what are we being asked to find? Grams of oxygen. What are we given? 25.6 grams of water. And remember, when you say C, an excess of something, I'm going to ignore it. And I also was given a balanced chemical equation. So what I'm going to do is I'm going to start with this, because this is the only number I have. I have my magic ratio. And what units do I want my answer to be? Grams of oxygen. And I know unit analysis, so I'm going to use it right now. Whatever I'm trying to get to goes on top. Whatever I'm trying to get rid of, units go underneath. I'm going to write those in. And I say, well, I got to find these numbers. Where can I find a relationship of grams of oxygen to grams of water? And guess what? It doesn't exist. This relationship does not exist. It just doesn't. So what do I do? That's a good question. Well, it turns out this is what you do. Mass calculations, mass meaning grams, for a reaction. Finding moles or mass of a substance in a chemical reaction. And really, I should take out this. That shouldn't be there. Finding the mass of substance. And there are 3 steps. Time for Dr. White to be subtle. And the first step is whatever you're given in grams, the mass, you convert to moles. And you know how to do that. And once you get the moles of whatever you just figured out from what you started with the grams of, you convert that moles of what you have from 1 in number 2 to the moles of the answer you want to get. And we just did that. And then the third step, whatever you just calculated the moles, you convert that moles to grams, the mass. And we did that last week. So you have to do all 3 steps. Now, good news. In the past, I used to make students memorize this. Say, you've got to memorize this so you can use it on the test. But, and let me open up something that I didn't. And everybody see, thumbs up people, help me out. Do you see test 2, important information on your screen? Thank you. And in test 2, important information, if you look at right here, I will give this to you, mass calculations for reactions. Step 1, whatever you're given in grams, you convert to moles. Step 2, now that you have moles of A, you convert to moles of B, what you're trying to get to, answer-wise. And then you convert moles of B to grams, your final answer. So again, 3 steps. So let's get to work. Since this isn't going to help us, because you can't do that, I'm going to erase it. Two days later, it'll be clean. It's easier on a real whiteboard, but all right, so we need 3 steps. Step 1, is grams or mass of A to moles of A. Well, in this case, what's A? Whatever we have to work with. So we want to go grams of water to moles of water. And how do we do that? Well, 25.6 grams of water. We want to get to moles of water. And so we'll use unit analysis. Whatever we're trying to get to goes on top. Whatever I'm trying to get rid of goes underneath. And where do we get that relationship? Well, in case you forgot, it's in test 2, important information. Oh, before I do that, I should write what moles of water, grams of water. And here, if you look at important information, test 2, 1 mole of a compound equals the molecular weight of that compound in grams. 1 mole of a compound equals the molecular weight of that compound in grams. And the molecular weight of that compound is the sum of all atomic weights. So now I can go back to my problem and say, for every 1 mole right here, I need the molecular weight of water. And that's 2 hydrogens, sum of all atomic weights, 1 oxygen. Remember, on test 2 and 3, 4 in the final, it will say, please use all atomic weights to 3 significant figures. I'm going to come down here. And the sum of all atomic weights is 18.02. Remember, for addition, you get the same number of significant figures to the right of the decimal as the number you're adding that has the fewest. In that case, this is 1, this is 2, drop that, and this should be 18.0. This is 3 significant figures. This is an exact number. This is 3 significant figures. If I look at this, I now have grams of water, I'll get my right answer. So now I'm gonna go to my calculator, clear it. I get the number 1.422222 times 10 to the 0. I'm gonna round it off because we're running out of time. And you get 1.42. Now we did step 1, we have to go to step 2. And that's going from moles of A to moles of B. In this case, moles of A, let me move my screen out of the way, is moles of water. And we're trying to figure out how many grams of oxygen. So in this case, B is oxygen. So I want to go to moles of O2. Well, I have 1.4, there should be a 2 here, 2 moles of water. I want to get to moles of oxygen. And I'll use unit analysis again. Whatever I'm trying to get to goes on top of the ratio. Whatever I'm going to get rid of goes underneath. So I have moles, O2, moles of water. Where do I get these numbers? Where do I get a relationship between moles of oxygen, moles of water? From the balanced chemical equation. When there's no coefficient, it's 1 mole. O2 makes 2 moles of water. And therefore, for every 2 moles of water, I need 1 mole of oxygen. These are exact numbers. Now, Notice moles of water cancel out because anything divided by itself is number one. I'll take 1.42 times 1 divided by 2. And my calculator gives me the number 7.10 times 10 to the minus 1. Am I done? No. I want to get to grams of oxygen, where now I have moles of oxygen. And so we have to do step number 3, moles of B to grams of B. In this case, it's moles O2 to grams O2. So we want to get to that. We'll start with this. So I have 7.10 times 10 to the minus 1 moles of oxygen. I want to get to grams of oxygen. So once again, I'll use unit analysis, your good buddy, your good friend. Whatever I'm trying to get to goes on top of the ratio. Whatever I'm trying to get rid of goes underneath. This is grams of O2. This is moles of O2. Where do I get these numbers? Well, if you look at important information, test number 2, 1 mole of a compound equals the molecular weight of that compound in grams, and the molecular weight of that compound is the sum of all atomic weights. So I'll come back here, and I know 1 mole equals the molecular weight. In this case of oxygen, how do I do that? I have 2 oxygens. Each oxygen is 16.0, multiply it 32.0. So up here goes 32.0. This is 3 significant figures. This is 3 significant figures. This is an exact number. And also notice moles of oxygen divided by moles of oxygen cancel out because anything divided by itself equals the number 1. And it's time for me to pick up my calculator. And my calculator gives me this number. And notice this is 4 significance. I have to round it off to 3, keep 2, keep 2, keep to 7. Use this to round off. It's 4 or less. So the correct answer is this. Wow, I timed it just perfectly. First of all, now you know why it's 10. Yes, 10 points. And we'll be doing more of these. And tomorrow, don't forget the lab we did last Tuesday. I think it was moving electrons lab is due tomorrow. If you have problems with the lab or anything else, come to my office hour tonight at 5 to 6:15. I'll be there on time this time, not like last Wednesday. Bad, Dr. White. But anyways, and also feel free tomorrow to ask me after class. And with that, Gang gesund. Bye. I'll see you tomorrow morning at 9.